Hi friends, today we look at a topic on speed math. Now what exactly do we mean by speed math? Okay, by name itself we can understand. Some of them may be understanding it how to do the maths faster. Okay, but please understand that speed mathematics is nothing but how to do the calculations faster. Now, when you're talking about calculations, okay, in CAT as well as other MBA entrance examinations, calculations play a very important role. Where does it play an important role? Especially in areas of quantitative aptitude and data interpretation. So, in your quant and data interpretation, the number of questions, if you observe, in quant you will be having something like 24 questions. In data interpretation, there will be something like 16 questions. So 34 questions plus 16 questions, that is how much? About 50 questions. Okay, you can see of mathematics where you need some calculations. Okay, so straight away we have entered into how to do the calculations faster. What we did? 34 plus 16 is nothing but 50 we got. Now let us say in every problem, assuming in every problem there is some calculations or the other. Now in every calculations, if you can save some time, let us say about at least 10 seconds time. If you are saying 10 seconds time in every question, that means total how many questions are there? About 50 questions. So every question 10 seconds time, meaning how many seconds you can save? 500 seconds, 10 into 50. That means if you are good in your speed maths, there is a chance that you can save nearly 500 seconds. 500 seconds is slightly more than 8 minutes. Okay, so 8 minutes you can save by being good in your calculations. Now what exactly do we mean by calculations? So for example, let us say you want to multiply 108 into let us say 112. The moment you look at 108 into 112, we have a technique with which we can say it as 120/96. Similarly, suppose if you want to find the value of 56 squared. When you look at 56 squared, you can write it as how much? 31/36. Or if you want to multiply, let us say you want to find the value of 107 squared is nothing but 107 into 107. Okay, we have a technique with which we can write it as 11449. This is what we are going to learn in the next couple of hours. Okay, so when you look at the speed max, for every problem you will involve some calculations or the other. If you can master these techniques, your speed will be much faster. Okay, now a question may be coming in your mind saying that CAT, there is a online calculator. On-screen calculator is available in the CAT exam. When on-screen calculator is available in the CAT examination, is it necessary for us to do or learn the techniques? Now let us see here. If you want to multiply 112 into 108, if you are using a calculator, how many times you have to press the key? 1, 2, 3, 4, 5, 6. Totally 3 digits and 3 digits, that is 6 digits. Okay, and then multiplication sign 1 and equal to symbol, that is totally 8. So 8 times you have to press the key. By pressing the key 8 times, that itself will take more amount of time. By just observation here, you can say that the result is 120/96. So is it necessary for us to use the calculator? Point 1. Point number 2. Are you writing CAT alone? Are you writing CAT examination alone, or you will be writing some other examination also? Okay, so when you are preparing for MBA, along with CAT, what other examinations you will be writing? You will be writing ZAT, you will be writing IAFT, you will be writing NMAT, you will be writing SNAP. That means along with CAT, you will be writing these 4 exams. Now CAT as a calculator. What about these examinations? Are they calculators? There are no calculators. Since there are no calculators here, and you need to crack this examination, Because of these reasons, it makes more importance for you to get a good grip on speed math. And the techniques what we are going to learn are very simple techniques. Okay, in the due course of time you will see how simple the techniques are. Okay, so when you're learning it, the important thing here is speed math is useful in our examination. But again, the moment you are preparing something for examination, what will happen? We'll prepare just before the exam. Take your example of your graduation exams. When did you study? Assume you study, right? When do you study? One day before the examination or one night? So when you're studying one day or one night before the examination, what happened? Everybody studied the examination in the similar manner. And you got a good percentage, maybe 70%, 80% or 90%. Okay. So what happened after examination is over? After examination is over, what happened? You may not remember anything what you have studied. Because if you're trying to take too many things in a short time, the faster you take, okay, the sooner it evaporates. The faster you take, the sooner it evaporates. So what will happen then? You study and then you forget. But please understand, in a competitive examination, when you're preparing it, you are studying to remember. Okay, remember at least till the date of the examination, that is at least from, exam starts from November, goes to, CAT is in the month of November, other examinations are in the month of December and January. So you are going to study today and you are going to remember till January. Okay, so please don't study only before the examination. You need to study on a daily basis. You need to study on a daily basis. So what we have to study? So once we see the speed maths, the techniques, okay, then we'll study speed maths every day for about something like 10-15 minutes time. More than sufficient. Now ask a question for yourself. In a day, how many hours are there? 24 hours, correct? Out of these 24 hours, how many minutes are there? 24 hours into 60 minutes. Out of this, I am asking you to study only something like 15 minutes on speed maths. How to study these 15 minutes? These 15 minutes, you can break it into 3 parts. Maybe morning 5 minutes, afternoon 5 minutes, and evening or night 5 minutes. So if you study 5 minutes at a stretch, that is more than sufficient for you to get a master in speed maths. And once you're good in your speed maths, what will happen is this speed maths is going to be useful not only in the examination but also useful in your day-to-day life. How is it going to be useful? Let us say tomorrow once you get admission in IIM, let us say Ahmedabad, and once you finish your MBA from IIM Ahmedabad, you will be joining a company as maybe a manager. As a manager, you will be giving presentations to your senior management. So let us say you are saying, if you say that in a presentation, you are showing a growth of 15%. Okay, and the 15% corresponds to, let us say, 230 crores. Your senior management says 15% is not sufficient. Okay, you need to show 20% growth. So what is the value here? So you can't tell the management just to hold on and then take a calculator, do the calculations and get the answer here. You need to be good in your calculations. Okay, how to do this is where speed maths is going to be useful in your day-to-day activities. How to do these calculations? Okay, that is what we are going to see in the next couple of hours. Okay, now before we enter into speed maths, the techniques, okay, there's something called prerequisites for a speed math. Now what are the prerequisites for a speed math? The first one is multiplication tables up to 20. You have to remember a multiplication tables up to 20. So starting from 1 into 1 is equal to 1. You have to remember till 20 into 20 is 400. How many days is it required to learn the tables? Some of you might be thinking you will take 1 day. Some of you might be thinking you will take something like 2 days. Some of them might be thinking you can do it within 1 or 2 hours. Please understand, couple of minutes back itself we discussed, you are studying not to forget, you are studying to remember. If you do it in 1 day or maybe half a day, what will happen? You learn, but there is a chance that you forget. So how to learn them? How much time it will take? Let us hear. Okay, to learn it, what you do is take a big white paper, okay, and first write the multiplication table of 11. 11 into 1 is 11, up to 11 into 20 is 220. Then from top to bottom, read it a couple of times. Don't try to mug up, just try to read. Okay, top to bottom, read it couple of times. Then again, from top to bottom, read a couple of times. Meaning 11 into 20, 220, 11 into 19, 209, 11 into 18, 198, 11 into 17, 187, 11 into 16, 176, like this. After that, now do randomly. So 11 into 4 is 44. 11 into 7 is 77. 11 into 11 is 121. 11 into 15 is 165. 11 into 18 is 198. 11 into 12 is 132. 11 into 8 is 88. Like this, if you practice, it will take not more than 5 minutes for you to learn the table. So what you do? Today, learn 11. Tomorrow, 12. Next day, 13. Like this, if you do it from 11 to 20, how many days is required? Maybe 10 days time. So take 10 days time, learn 1 or 2 tables every day and keep revising it. Now what is the use of these tables? Okay, useful in calculations. Also, it may be useful in solving a problems in mathematics. Okay, suppose if you have a question like, let us say 91 divided by 10 minus c plus 91 divided by 10 plus c is equals to 20. What is the value of c? This is a question. 91 by 10 minus c plus 91 by 10 plus c is equals to 20. So some of you may be doing a LCM, cross multiply, and then do the problem. If you're good in your numbers, okay, the moment you look at 91, what you can remember it as? The moment you look at 91, you can recollect it as if you're good in your tables. It is nothing but 7 into 13. So 7 into 13 is 91. And if you look at 20 here, 20 is also nothing but 7 plus 13. Then if you look at the equation, you can say that this question has something to do with 7 and 13. Correct? So 7 and 13 means I can write this is if it is 13 and this is 7. That is nothing but 13 plus 7 is 20. So if you want to get 13 here in the numerator, 91 by what number gives us 13? Yes, this has to be 7. And 91 by what number gives us 7? This has to be 13. If you observe these two numbers, 13 and 7, this is nothing but 10 minus 3 and this is 10 plus 3. Okay, so what is the value of C here? Value of C is nothing but 3. So value of C is 3. If you observe here, in this equation, the moment you write the equation, once you're good in your calculation, that means in your tables, the moment you look at 91 and 20, you can recollect as 7 and 13. And you can see how fast the problem can be solved. No need to write the equation, no need to take the LCM and then do all of them. If everybody is doing in that way, you being good in your tables, you can solve the problem in this way. Okay friends, so similarly let us take one more example. Let us say if sum of two numbers is 25. Sum of two numbers is 25 and let us say the product of the numbers is 100. So what you can say here? Sum of the numbers is 25 and the product is 100. So I can write this as 100 is nothing but 20 into 5. What is the sum of these two numbers? 25 and the product is 100. Suppose if I say the sum of two numbers is 25 and let us say the product is 84. So what you can say? 84 is nothing but what? 21 into 4. 21 into 4 is 84. 21 plus 5 is 25. 21 plus 4 is 25 and 21 into 4 is 84. So similarly, if you have, let us say, now let us go slightly bigger numbers. Suppose if you say sum is if say sum of the numbers is 25 and the product is let us say 150. So what you can say? 150 is nothing but 15 into 10. 15 into 10 is 150. 15 plus 10 is 25. Okay. So friends, if you are good in your multiplication tables, you can find out these values. This is where tables play a important role. Similarly, you can talk about 19 and how much? 6. You can say 18 and 7. 17 and 8. Like this, it continues. Okay. So, if the sum of two numbers is given and the product of the numbers is given, if you are good in your multiplication tables, you can get the answer very, very fast. Okay. This is the first prerequisite. Now, what is the next prerequisite? The second prerequisite is nothing but squares up to 25. Okay. So, again, please take a couple of minutes time. Write down 1 square is 1, 2 square is 4, up to 25 square. 25 square is how much? 625. Okay, please make a note. Let us do it together. Okay, so what is 3 square? 9, 4 square, 16, 5 square, 25, 6 square, 36, 7 square, 49, 8 square, 64, 9 square, 81, 10 square, 100. Next, what you have? 11 square, 121, 12 square, 144, 13 square, 169, 14 square, 196, 15 square, 225, 16 square, 256, 17 square, 289, 18 square, 324, 19 square, 361, 20 square, 400. Then we have 21 square, 441, 22 square, 440, 484, 23 square, 529, 24 square, 576, and 25 square is how much? 625. Friends, you have to remember the squares up to 25. Once you remember the squares up to 25, we will be learning a technique. With a technique, within 5 seconds time, max to max of 5 seconds time, you can find the square of any number up to 125 and beyond that also. Okay, but for you to do that faster, you need to learn the squares. What's the next thing that is important? The next thing that is important is what? So you have to remember cubes up to 12. So let us make a note of it. 1 cube is how much? 1. 2 cube is 8. 3 cube is 27. 4 cube is 64, 5 cube is 125, 6 cube is 216, 7 cube is 343, 8 cube is 512, 9 cube is 729, 10 cube is 1000, 11 cube is 1331, and last one 12 cube is 1728. Okay, now where does the cubes play an important role? Again, while solving in your quant or maybe in your data interpretation, okay, if you come across Somebody asks you what is 11 cube. 11 cube is nothing but what? 1331. Or suppose they say that 1728. What is 1728? 1728 is nothing but 12 cube. If they say 343. 343 is nothing but what? 7 cube. 512. 512 is 8 cube. That means you have to remember in both directions. 6 cube is 216. 216 is nothing but 6 cube. 8 cube is 512. 512 is nothing but 8 cube. That is how you have to remember. If suppose somebody asks you what is 729. 729 is nothing but what? 9 cube. So where it is going to be useful? Let us say there is a chapter called simple interest and compound interest where in the compound interest it is nothing but given as 1.2 whole cube. The formula will be 1 plus r by 100 whole power n. Where it is r is 20 percentage, so 20 by 100 is 0.2, so you will get in the form of 1.2 whole cube. The moment you get 1.2 whole cube, there you have to be in a position to say that it is 1728. So once you remember this cube, while solving the problems, you will be much faster. Next one is reciprocals. What do you mean by reciprocals? That we'll be seeing later. Just to give you an idea what are reciprocals. Reciprocal is nothing but 1 by 2. For example, 1 by 2 is in the form of fraction. If you convert in the form of a percentage, that will be 50 percentage. Similarly, 1 by 3 is how much? 33.33 percentage. We'll spend more time on reciprocals while we are solving the percentage calculations. Next area will be powers of 2 up to 12. So please make a note of powers of 2 up to 12. Meaning you have to write 2 power 0 is 1, 2 power 1 is 2, like this. Up to 2 power 12 is how much? 4096. So please ensure that in your book you make a note of powers of 2. Similarly, you will have powers of 3 up to 6 or 7 is sufficient. Powers of 3 is nothing but, again the same way, 3 power 0 is 1, 3 power 1 is 3, 3 square is 9, 3 cube is 27, 3 power 4 is 81, 3 power 5 is 243, 3 power 6 is 729, 3 power 7 is 2187. And last one, is called as complements of 100. What do you mean by complements of 100? If the sum of two numbers is 100, those two numbers are called as complements of 100. Example, 80. What is the 100 complement of 80? 20. So 80 and 20 are called 100's complement. 75, 25. 70, 30. 40, 60. 55, 45. 36, 64. 71, 29. 37.5, 62.5. 54.6, 45.6, 75.2, 24.8. These are the complements of 100. What is the use of complements of 100? While solving the problems, especially when you're doing the calculations, additions and subtractions, or maybe to an extent multiplications, complements of 100 play a very important role. So friends, we'll start with a very simple techniques on additions. If you remember additions when we learned, when we are in a school, maybe the first thing what we have learned is how to add two numbers. Now again, we'll see how to add two numbers in a slightly different fashion. Example, if you have, let us say, 2345 plus 5623. 2645 plus 5623, what is the result? Now some of you, when you are adding, you may be adding it is 5 plus 3, 8. 4 plus 2, 6. Some of may be using the fingers. 6 plus 3, 7, 8, 9. Please don't use the fingers. Fingers are meant for eating and other things, not to add the numbers. So this will be 9 and this will be 7. If you observe what is that we have done. we have written the numbers in this direction, from right to left. Remember, whenever you are trying to get the speed, okay, you need to write the numbers from left to right. There's how much here? 7970. Okay, now 2345 plus 5625 is 7970. Similarly, if you have, let us say, 5374 plus 1234. So how much you'll be getting here? 6608. Okay, let us take one more example. 7654 plus 8765. So how much you'll be getting here? I am right. 8 plus 8, 16. 16, 14, 1, 9. So let us take one more example. 4567 and 7895. So how much you'll be getting here? 1, 2 good. This is 4 good. This is 6 good. This is 2. Okay, let's take one more example and last one, and then we move to the next thing. Suppose if you have, let us say, a numbers like 3786 and 8739. So how much you'll be getting here? 1, 2, 5, 2, 5. Simple. Let us say 5678 and 4321. So how much you'll be getting here? 9999. Okay, so please remember, whenever you are adding two-digit numbers or adding the numbers, always try to write the numbers from left to right. This is important. Always write the numbers from left to right. Never write the numbers from right to left. Now, what's the difference? If you are writing the numbers from right to left, meaning you are doing a single digit calculations. But if you are writing the numbers from left to right, meaning you are doing the mental calculation and putting the result on the board. So as far as possible, try to do as orally as possible. Now let us look at if you have additions of this type. Okay, then what are we going to do? That means here, okay, you are having not two digits, not two numbers, but you are having 1, 2, 3, 4, 5 numbers. And each number is a 4-digit number. Now how to add the numbers? Some of you might be adding like 5 plus 5, 10, 10 plus 6, 16, 16 plus 4, 20, 20 plus 4, 24. 4 carry 2. Then you might be doing 4 plus 2, 6, 6 plus 6, 12, 12 plus 5, 17, 17 plus 5, 22, 22 plus 2, 24, 4 carry 2. Like this if you are doing. If you are doing like this addition, meaning how many times you are adding a single digit number? 1, 2, 3, 4 times you are adding, which will take you more amount of time. So whenever you are having this kind of problem, the faster way of doing the addition is what? The method says, okay, take 2 digits at a time. So what are 2 digits here? 45, 65, 56, 54, 24. These 2 digits at a time, take and add, and other 2 digits will be 23, 57, 45, 76 and 80. Okay, now how to add these 2 digits? Okay, now the method will be take the number, add the units digit of the next number. That means 45 plus 5. 45 plus 5 is how much? 50. 50 plus add the tens digit value. That is how much? 60. So 50 plus 60 is 110. 110 plus 6, 116. 116 plus 50, 166. 166 plus 4, 170. 170 plus 50, 220. Plus 4, 224. 224 plus 20, 244. So 44 carry 2. Okay, now if you observe, okay, what we are doing here, 45 plus 5 plus 60 plus 6 plus 50 plus 4 plus 50 plus 4 plus 20. Like this, if you keep on saying the word plus, that itself is a waste of time. You know that you are going to do the addition. Okay, so try to do is orally without using the word plus. Okay, what is the method? Add a units digit and then go for a tens digit. Let us see. 23, 25, 32, 82, 87, 127, 133, 203 and 283. So 28344. Okay. Now let's move to the one more example. Okay. Now when you're doing this example, let us do it together fast. 48, 50, 130, 136, 226, 235, 295, 300, 370. 70 carry 3. Okay. 32, 35, 42, 92, 101, 141, 201, 204, 284. Okay. Now let's move to the next one. Now practice this. So how much you are getting? Let us see. Take maybe 10 seconds time or 20 seconds time. Add the numbers. Your time starts now. Got it? Let us start. Let us see. 56, 65, 105, 107, 177, 179, 219, 226, 306, 06 carry 3. 43, 46, 49, 109, 159, 160, 2, 230, 2, 3, 1, 2. So going forward, let us see one more additions. So how much you are getting here? I can take 20 seconds time and add the numbers. Your time starts now. Stop it. How much you are getting it is? It is 31342. If some of you made any mistake, don't worry. Okay, just practice for one more and then we'll say it. So how much you are getting here? I can take 20 seconds time. Now try to concentrate and push. Don't think anything else. Just concentrate on the numbers like this. 76, 85, 165, 172, 312 like this. So how much you are getting here? 395, 95 carry 3. Add in the same way. 46, 49, 56, 116, 124, 174. Do it. So how much you are getting here? 3, 2, 5. And the previous number was what here? 31342. The previous number is how much? 31206. The previous number was what? 28470, and the first one was what? 28344. Now exactly if you observe what is that we are seeing here. Now when you are talking about additions, how and where the additions are important and they play important role. Now if you observe, we nothing but we can see a table here where you have data in the form of rows and columns. Suppose if I say this is a production of rice, the production of wheat, maize, sugar, and let us say bajra for the various years for 2012-13, 2013-14, 2014-15, 2015-16, and 2016-17. This is nothing but, you can observe, it's a table. So this kind of questions will come in the data interpretation. Now the questions come in the data interpretation. Nobody will be asking you what is the total production of the food grains for a given period. They won't ask you that. They won't ask you a question like what is the total production of all the food grains for the year 2015-16. They may not ask you. What question they will be asking you is wheat forms what percentage of total food grain production for a given crops for the year 2015-16. So how to solve? Wheat is what percentage of the total food grain production for the year 2015-16. So 2015-16, wheat is having how much here? 5937 divided by the total food grain production. Total food grain production is nothing but 31342. Then you have to multiply and find the percentage. Okay, this is what questions will be asked in data interpretation. Okay, so here if you observe, when you find a total food grain production for the year 2015-16, what is that we do? We need to do the additions. Okay, so this problem involves additions as well as percentage calculation. How to do this percentage calculation, that we will see after some time. But now we have seen how to do the addition. Or there may be a question like what is the total wheat production of wheat for a given period. So what will you do? Is asking total production of wheat for a given period, meaning this is what you need to add the values. I know you're adding the values, some of them might be having a habit of writing like this 5765, 5782, 6349. Okay, like this, they might be adding the values and then solve the problem, which will be a waste of time. Never write down the values. Try to do it orally, like this 65, 67, 147, 147, and then plus 9, plus 40, plus 7, plus 30, like this. So you need to add the figures in a horizontal manner. Okay, this is where the importance of additions comes in. Okay, now let's move to the next concept about the squares. Now before we are looking at the squares, okay, there are many methods of finding the squares. Now let us look at finding the square through a odd number concept. What do you mean by odd number concept? Okay, what are odd numbers? Let us write down. So odd numbers are nothing but you have 1, 3, 5, 7, 9, 11. Like this, these are odd numbers. So if I take the first two odd numbers, what is sum of the first two odd numbers? 1 plus 4, that is 1 plus 3, that is 4. If I take sum of the first three odd numbers, what is the sum of the first three odd numbers? 1 plus 3 plus 5. 1 plus 3 plus 5 is how much here? 9. You look at sum of the first four odd numbers. 1 plus 3 plus 5 plus 7, that is nothing but 9 plus 7, which is 16. So next odd numbers, these odd numbers will be how much here? 16 plus 9, that is 25. What you can observe here? First number odd number is 1. Sum of the first two odd numbers is 4, that is nothing but 2 square. Sum of the first three odd numbers is 9, that is 3 square. Sum of the first four odd numbers is 16, that is 4 square. Next is 5 square. That means if you take sum of the first n odd numbers, sum of first n odd numbers is nothing but what given as n square. Sum of the first odd numbers, friends, is given as n square. Okay. If suppose somebody asks what is the sum of the first 10 odd numbers. Sum of first 10 odd numbers will be how much? 10 square, that is 100. Sum of the first 20 odd numbers. Sum of the first 20 odd numbers is what? 20 square, which is 400. Sum of first 25 odd numbers. Sum of the first 25 odd numbers is what? 25 square. 25 square is how much? 625. Sum of the first 30 odd numbers will be 30 square, that is 900. Okay, so this is what the sum of the odd numbers. Okay, now how to find the squares through this odd number concept? So now before we look at the concept, now let us find out how to find the square of a number ending in 5. Square of a number ending in 5. Example, if you have 15 square, what is 15 square? 15 square is nothing but what? 225. 25 square is how much? 625. 35 square is how much? 1225. I am writing the numbers in a particular fashion. Okay, and now you need to observe what you can observe there. Okay, so what is the 45 square? What is the first observation you can do here? You look at in these three numbers. Okay, let me write down this also for you. 45 square is nothing but 25. So what is the first observation you can make? The first observation you can make here is all the numbers are ending in 25. That means how we are getting 25? 5 square is nothing but 25. So tomorrow somebody asks you what is 65 square? 65 square, the first observation what you can make? 65 square, the first observation is 5 square. 5 square is how much here? 25. Suppose somebody asks you what is 75 square. What is the first thing that you can write? 5 square is 25. Now what is the second observation? The second observation is 1 is becoming 2 here, 2 is becoming 6 here, 3 is becoming 12 here, and 4 is becoming 20 here. So what is the first observation you can make? 1 is becoming 2, that means 1, the next number is 2, so 1 into 2 is 2. 2 is here, the next number is 3, so 2 into 3 is 6. 3 is here, the next number is 4, so 3 into 4 is 12. 4 is here, the next number is 5, so 4 into 5 is 20. Similarly, we have 6 here, the next number is 7, so 6 into 7 is 42. 7 is here, the next number is 8, so 7 into 8 is 56. Suppose if you have, let us say, 95 square. 5 square is 25. 9, the next number is 10. 9 into 10 is 90. So 90, 25. Suppose somebody asks you 95 square. What is 95 square? 5 square is 25. 9, the next number is 10. 9 into 10 is 90. 90, 25. Suppose if you have, let us say, 115 square. Method is same. What is the method? 5 square is 25. Next is what? 11 is other number. 11. After 11 was the next number? 12. 11 into 12. 11 into 12 is how much? 132. You can see the importance of multiplication tables here. Okay. Suppose if you have, let us say, 145 square. 5 square is 25. 14. The next number is 15. What is 14 into 15? 210. If you can't remember 14 into 15, I'll tell you for today's class, I'll tell you one more technique. So what is that you have to do? 14 into 15. So 15 you can write it as what? 14 plus 1. So 14 into 14 is nothing but 14 square plus 14. So the best method of doing it is 14 into 15. Since we have not learned the tables yet, what is the other method of doing it? Squares we have learned, remember that. So 14 square plus 14, we are making the use of the squares. 14 square is how much? 196. 196 plus 14. How to add the numbers we have seen. 196 plus 4 plus 10. Units digit plus tens digit. That is how much here? 210. Okay, suppose if you have, let us say, 165 square. So 5 square is 25. 16 into 17. Or what is the other method? If you remember 16 to 17, best. If you don't remember, the other method is what? 16 square plus 16. What is 16 square? 256 plus 16. That is how much? 272. This is how you can find the square of a number ending in 5. So now we make use of these two things to find the square of a number ending through odd number concept. So how to do it? Let us see here. Suppose you want to find, okay, what is the sum of, let us write down like this. Sum of first 10 odd numbers is nothing but 10 square. Okay, sum of, okay, 76 odd numbers will be how much here? 76 square. Now sum of 76 odd numbers, I can write it as sum of 75 odd numbers plus 76 odd number. That is nothing but what here I can write 76 square. Or somebody asks you what is 76 square. 76 square, how can you write? In the rearranging the terms, it is nothing but sum of 75 odd numbers. What is sum of 75 odd numbers? Sum of the first 10 odd numbers is what? N square. Okay, so sum of first 75 odd numbers is 75 square plus 76 odd number. Okay, suppose if somebody asks you what is 66 square, let us say. 66 square is nothing but what? Sum of the, looking at the previous step, what we can say it is 65 square plus 66th odd number. If they ask you 36 square, 36 square will be what? 35 square plus 36th odd number. So basically what we are doing, we are finding out one more than the square of a number which we know. Suppose they ask you what is 51 square. 51 square will be what? 50 square plus 51st odd number. Similarly 41 square. 41 square will be what here? 40 square plus 41st odd number. That means what we are trying to do here? We are trying to find the square of a number which is one more than the square of a number which we already know. Meaning 75 square I know. How to find one more than this? That is 76. 50 square I know. One more than 50 square is 51 square. How to find out? This is what we are trying to do it. Okay. So now let us write it once again. So now let us look at how to find the square of a number which is one more than the square of a number which we know. Let us start with 51 square. 51 square is nothing but 50 square plus 51st odd number. Since we are doing it for the first time, I am writing here. So 50 square is how much here? 2500 plus 51st odd number. 51st odd number will be, how to find odd number? Odd number is nothing but 2n minus 1. So here 51st odd number will be 2 into 51 minus 1. So 2 into 51 is how much? 102. 102 minus 1. That is how much here? 2500 plus 101. So this will be 2601. Okay. Now let us take one more example. Let us look at 61 square. 61 square will be what? 60 square plus 61st odd number. Let us try to do it orally. So 61 square will be what here? 60 square, that is 3600, plus 61st odd number, double the number, minus 1. 61 double is how much? 122 minus 1 is 121. So how much will be here? 3721. Okay. Now let us look at 71 square. 71 square will be 70 square, that is 4900, plus 71st odd number. How to get 71st odd number? Double the number, minus 1. 71 double, 142 minus 1, 141. That is how much here? 5041. Similarly, if you have, let us say, 31 square. 31 square will be 30 square 900 plus 31st odd number, double the number, minus 1. 31 double, 62. 62 minus 1 is 61. So 900 plus 61, that is 961. Let us look at 41 square. 41 square is how much? 40 square 1600 plus 41st odd number. 41st odd number is double the number, minus 1. 41 double, 82 minus 1 is 81. So 1600 plus 81, 1681. Okay. Similarly, if you want to find 91 square, let us say, 91 square will be what? Double and 90 square, that is 8100 plus 91 double minus 1. 91 double is 182 minus 1 is 181. So how much you get here? 8100 plus 181. So 8281. Okay. Now let us look at 56 square. 56 square will be what? Again it is one more than the square of a number which we know. One more is how much here? 55 square plus 56 odd number. So 55 square is how much here? 5 square 25. 5 into 6 30. So how much you get here? 30 25 plus 56 odd number, double the number, minus 1. 56 double is how much? 112 minus 1, that is 111. So how much you get here? 3136. Similarly, 66 square. 66 square will be what? Double the number, 65 square, that is 4225 plus 65th sixth odd number, double number, 132 minus 1, that is 131. So how much you'll be getting here? 4356. 76 square. 76 square will be what? 75 square, that is 120. 75 square is how much? 5625 plus 76 odd number, double the number, that is how much? 152 minus 1, that is 151. So how much you'll be getting here? 5776. Okay, now friends, we have seen how to find the square of a number which is one more than the square of a number which we know. Now let us look at how to find the square of a number which is one less than the square of a number which we know. When talking about one less than the square of a number which we know, okay, it's like this. So instead of finding more, what we are trying to do, one less we are doing. So here 51 square is nothing but 50 square plus 51st odd number. So if you want to find 50 square, how much it will be? 51 square minus 51st odd number we'll get. Okay, that means, for example, if you look at 49 square, 49 square will be what? 50 square minus 50th odd number. 50 square is 2500 minus 50th odd number. How to get 50th odd number? Double the number, minus 1. Double the number is 100. 100 minus 1 is 99. So how much you get here? 2401. Okay, let us take one more example. Okay, let us take it as 39 square. 39 square will be what? 40 square. 40 square is how much? 1600 minus 40th odd number. 40th odd number is double number, minus 1. 80 minus 1 is 79. So how much will you get here? 1521. Okay, let us look at 59 square. 59 square will be what here? 60 square, that is 3600, minus 68th odd number, 120 minus 1, that is 119. So how much you will be getting here? 100 minus 19, that is 81. Okay, 35 minus 1 is 34. So 3481. Okay, suppose if you have, let us say, 69 square. 69 square will be what here? 70 square 4900 minus 78th odd number. 78th odd number means double the number minus 1. 140 minus 1 is 139. So how much you will be getting here? 100 minus 39 or 100 complement, 39 complement of 100, that is nothing but here 61. And 49, 1 has been removed, so 48 minus 1 is 47. Similarly, if I let us say 119 square, the same method. 119 square will be how much? 120 square. 120 square is 144,000 minus 128th odd number. 128th odd number is 240 minus 1, that is 239. So 100 minus 39, that is again 61. Okay, and then how much will be getting here? 143 minus 2, that is 141. Okay, suppose if you have, let us say, 54 square. Again 54 is 1 less here than 55. 55 square is how much here? 5 square 25, 5 into say 6 is 30. So 30 25 minus 55th odd number, double the number minus 1, 55 double 110, 110 minus 1 is 109. So 25 minus 9 is 16, 30 minus 1 is 29, 2916. 64 square, 65 square, so 4225 minus 65th odd number. 65th odd number will be 130 minus 1, that is 129. So 25 minus 29, that will be how much here? 96. 42 or 41 minus 1, that is 40, 4096. So this is how you can find for a square of a number which is 1 less than a square of a number which we know. So moving ahead, we look at, we found one more and one less. Now what we have to do, we need to find out two more. Two more than a square of a number which we know. That means I know 50 square, two more. Two more is how much here? 52 square. 52 square is nothing but what you can do? 50 square plus 51st odd number plus 52nd odd number. This is what you'll get. So instead of finding out 51st odd number and 52nd odd number, the other way of doing here is 50 square plus 4 times the middle number. The middle number between what? The middle number between 52 and 50. What is the number which is in between 52 and 50? 51. So it is 4 times 51. So 50 square is 2500 plus 4 times 51 is 204. So how much you will get here? 2704. So how to find a square of a number which is 2 more? Okay, it is square of a number, what we know, plus 4 times the middle number. Let us take one more example. Okay, 62 square. 62 square will be how much here? 60 square plus 4 times 61. 60 square is 3600 plus 4 into 61 is 244. So this will be 3844. So let us take, now let us try to improve our speeds. Okay, so 72 square will be how much here? 70 square 4900 plus 4 times 71 284. So how much will you get here? 5184. Okay, 32 square. 32 square will be how much? 30 square 900 plus 4 times 31, that is 124. That will be how much here? 1024. Getting it? Now let us take one more example. Okay, one more example. Let us look at 122 square. 122 square, in the same logic, what will happen? 120 square, that is 120 square is 12 square, that is 144 with 2 zeros plus 4 into 121. 4 into 121 will be how much? 484. So how much will you get here? 14884. If you have, let us say, 132 square. 132 square is how much? 130 square, 169,000 plus 4 into 131, that is 524. So how much will be getting here? 17424. Okay. Now let us look at something like 37 square. 37 square will be 35 square. 35 square is how much? 1225 plus 4 into 36. So 4 into 36 is how much? 144 minus 144. 4 into middle number, 4 into 36, that's 144. So how much will be getting here? 1369. Let us look at 57 square. 55 square is how much? 3025 plus 4 into 56. 4 into 56 is how much? 224. So how much will be getting here? 3249. Okay. Even if you are, let us say, 127 square. 127 square also the same method. What is the method? 125 square. What is 125 square? 12 into 13. What is 12 into 13? 156. So 156 25 plus 4 into 126. 4 into 126 how much? 504. So how much will be getting here? 16129. So we have seen how to find the square of a number which is 2 more. Now what should we do? How to find the square of a number which is 2 less than the square of a number which we know. 2 less, meaning, let us take an example. Let us look at 48 square. 48 square meaning we know the square of a number which is 50. So it has to be 50 square minus 4 into the middle number. The middle number here is 49. Okay. So 50 square is how much here? 2500 minus 4 into 49. How to find 4 into 49? You can say 4 into 40, that is 160 plus 36, that is 196. Or you can say 4 into 50, that is 200 minus 4, that is 196. Okay. So 100 minus 96, that is 04. And then you will have 24. 24 minus 1, that is 23. So 2304. Let us take one more example. Let us look at 58 square. 58 square is how much? 2 less than the square of a number which we know, that is 2 less than 60 square minus 4 into 59. So 60 square is 3600 minus 4 into 59. So it is 200 plus 36. So 236 or 240 minus 4. So here 100 minus 36, that is 64. Now you can see the use of complements of 100. Okay. So 35 minus 2. 35 minus 2 is how much? 33. So 3364. Okay. Suppose if you have, let us say, 53 square. 53 square is 2 less than 55. So 55 square we know minus 4 into 50 middle number, that is 54. So 55 square is how much here? 5 square 25. 5 into 6 30. So 30 25 minus 4 into 54. So 4 into 50 is how much? 200 plus 16, that is 216. 25 minus 16, that is how much here? 0, 9. Then 30 minus 2, that is 28. So 2809. Okay. If you have a bigger numbers also, the logic is same. So when you're talking about bigger numbers, let us look at example 88 square. 88 square is how much? 2 less than 90. 90 square we know. 90 square is how much? 8100 minus 4 into 89. What is 4 into 89? 320 plus 36. That is 356. So 8100 minus 356. So how much you will be getting here? 100 minus 56, that is 44. 80 minus 3, that is 77. Okay, so let us take one more example. Okay, let us look at 83 square. 83 is how much less? 2 less than the square of a number which we know, that is 2 less than 85. 85 square is how much? 5 square 25. 8 into 9, that is how much? 72. 7225 minus 4 into 84. 4 into 84 is how much? 320 plus 16, that is 336. So 7225 minus 336. So here how much you'll be getting here? 125 minus 36. How much is 125 minus 36? 64 and 25. So what I am doing here is, here, this when you're talking about 100 here, 125. So 125 is how much more than 100? 25 more. Okay, that's what we are thinking, 25 more. And 36 how much less than 100? 64 less than 100. So difference will be how much here? 89. Next is 72. 1 has been carried. So 7100 minus 3. That is how much? 68. So friends, okay, this is how we have to find the square of a number which is 2 less than the square of a number which we know. So friends, to recollect whatever we have seen till now, what we have seen how to find the square of a number which is 1 more than the square of a number which we know. Then we have seen how to find the square of a number which is 1 less than the square of a number which we know. Then we have seen 2 more and 2 less. So 1 more is what? How to find the square of a number which is 1 more? Let us take with an example. Okay, 1 more is, let us start with 51 square. 51 square, how to get it? 50 square, that is 2500 plus 51st odd number. 51st odd number is what? 2 into 51, that is 102 minus 1, 2n minus 1. So that will be 101. So how much you are getting here? 2601. Okay, 1 less. 1 less is how much here? Let us look at 49 square. 49 square is how much? 50 square, 2500 minus 58 odd number, that is 2 into 50 is 100. 100 minus 1 is 99. So how much you are getting here? 100 minus 99 is 01. 25 minus 1 has been taken, so 24. Then we have seen 2 more. 2 more is 52 square. 52 square, how to get it? 50 square, that is 2500 plus 4 into the middle number. Middle number is what here? 51. So 4 into 51. So 4 into 51 is how much? 204. So if you add 204 to this, how much you get here? 2704. Then 2 less we have seen. 2 less is, let us take an example of 48 square. 48 square, how to get it? 2500 minus 50 square minus 4 into the middle number. In this case it is 49. So that is how much? 2500 minus 4 into 49. 4 into 49 is how much? 4 into 49 is nothing but 200 minus 4, that is 196. So 100 minus 96 is 04 and 24 minus 1 is 23. This is how we can find the square of a number, square of any number. This is one method of doing it. Now let us look at the another method of doing the square of a number. Okay, to understand the logic, let us look at we have seen a square of a number ending in 5. Now let us look at how to find the square of a number in this range. So the numbers, what we do, we divide the numbers in different ranges. Okay, 26 to 50 is one range, 51 to 75 is one range, 76 to 100 is one range, and 101 to 125 is one range. Out of these ranges, let us start with any one of them. Let us start with 101 to 125. This second method of finding the squares. So when you're finding 101 to 125, the method is like this. Okay, let us take an example, 104 square. 104 square is a two-step process. The two-step process, step 1 is, first find out how much is the number more than 100. Here we are comparing the number with 100. How much is 104 more than 100? It is 4 more. So first step is find the square of it. The second number part is, for the number, what's the number we have? 104. For the number, add how much it is more than 100. How much more than 100? 4 more. So 4 square is 16. 104 plus 4 is 108. That's it. So this method appears to be more simpler, right? Let us take one more example. 106 squared. What is the first step? Find out how much it is more than 100. How much it is more? 6 more. So 6 square is 36. What is the second part? 106 plus 6. That is how much here? 112. Okay. 109 square. 109 square in the same method. How much more than 100? 9 more. 9 square is 81. So 109 plus 9. That is how much here? 118. Okay. So even if I let us say 111 square. 111 square is how much? Be careful. Okay, some of you might be writing it is 1 square. Okay, 111 is how much more than 100? 11. 11 square is how much? 121. Please be careful here. If you observe, in the first part, we have always written a 2-digit number. Okay, but here you got 121, which is a 3-digit number. So what to do with the 3-digit number, that we'll see now. So second part is the same, 111 plus 20. 111 plus 11, that is nothing but 122. Since it's a 3-digit number, what you do is take the 100th digit and add it here. So you'll get it as 123, 21. Basically, it is read as what? It is read as 122 hundreds plus 121. That's how it is being read as. Okay, let's take one more example. Let us take 116 square. 116 square will be how much here? How much it is more than 100? 16. 16 square is how much? 256. So 56 carry 2. Okay, next is what? 116 plus 16, that is 132 plus 2 has been carried. So it is 134. 1, 3, 4, 5, 6. Suppose now let us say interesting one, 103 square. What will be 103 square? How much it is more than 100? 3 more. 3 square is how much? 9. 9 is a single digit number. So what should be writing? You have to write it as 09. Always it's a 2-digit number. So what is the other part? 103 plus 3. That is how much? 106. Okay. Even if you have a number, let us say like 101 square. What is 101 square? 1 square is 1 only. So 01. 101 plus 1 is 102. So if you have a number, let us say 112 square. 112 square is how much here? 12 square is 144. 44 carry 1. Next is 112 plus 12, that is 124. 1 has been carried, so it is 125. Okay. So even if you have a bigger number, let us say like 121 square, the method is same. What is the method? 21 square. What is 21 square? 441. Okay. So 41 carry 4. Next part is 121 plus 21, that is 142. 142 plus 4 has been carried. So 146. 146, 4. So now let's look at how to find the square of a number which is in the range of 76 to 100. Okay. Now 76 to 100, when we are looking, it is less than 100. Now when you have a number, to find the square of a number which is less than 100, what is the method? It is a similar method what we have seen just now. Okay, 76 to 100, the similar method in the sense, let us take an example of 96 square. Now the number is less than 100 by how much? It is 4 less than 100. So first step is what? 4 square. Second step is what? From the number, what is the number we have here? 96. From the number, subtract how much it is less than 100. How much less than 100? 4 less. So 4 square is 16. 96 minus 4 is 92. Let's take one more example. Okay, 94 square. 94 square is how much less than 100? 6 less than 100. So 6 square is how much? 36. Second part will be how much? 94 minus 6. What is 94 minus 6? It is 88. Suppose if you add, let us say 97 square. 97 square is how much less than 100? It is 3 less than 100. So 3 square is how much? 9. So single digit number. So we have to write it as 09. Okay. Second part will be how much? 97 minus 3. 97 minus 3 is how much here? 94. So 9409. Okay. Let us take one more example. 89 square. 89 is how much less than 100? 11 less than 100. So 11 square is how much? 121. That's the first part. The second part will be 89 minus 11. That is how much here? 78. Since it's a 3-digit number, so what shall we do? Take this one and add it here. So how much will be getting here? 78 plus 1, that is 79, 21. 88 square. 88 is how much less than 100? 12 less than 100. 12 square is 144. So 44 carry 1. Second part will be what here? 88 minus 12. That is how much? 76. Okay, 1 has been carried. Add that value. So it will be 76 plus 1. That is 77. 77, 44. Okay friends, this is how we have to find the square of a number which is in the range of 76 to 100. Okay, now let us move to the next part, that is how to find the square of a number, okay, which is 51 to 75 range. Now let us see how to get it. Now method is same with a slight modification here. What is the slight modification? Okay, the slight modification here is for the numbers in the range of 26 to 50 and 50 to 75. That means for numbers in the range of 26 to 75, we have to take a base number. The base number, we have to take it as 25. So we'll take 25 as the base number. What is this base number? How are we going to use the base number? We'll see with an example. So let us start with 51 to 75. Let us look at 54 square. 54 square, the first part is how much? Compare the number with 50. The first part is compare the number with 50. How much is 54 more than 50? It is 4 more. So first part will be 4 square. So what is the second part? It is not 54 plus 4. Okay, this is where the change comes in. The second part will be take the base number, that is 25, and add how much it is more than 50. How much more than 50? 4 more. So 25 plus 4, that is 29. 4 square is 16. Okay, this is a technique. Now again, if you observe this technique, friends, what we are actually doing here, okay, it's nothing but, okay, we are applying a formula called a plus b whole square. Now many people keep asking me what is the difference in the questions that what we have studied in a school examination and in a board examination. So, board examination and the competitive examination. The questions are the same. There is no change. But the approach towards the questions will be different. Okay, in a competitive examination, we need to be fast. We need to apply the result. Now let us look at here. What exactly we are doing. We know the formula for a plus b whole square. A plus b whole square is nothing but what? A plus b whole square is nothing but a square plus 2 into ab plus b square. This is a formula which we have learned in our school. Okay, now when we want to apply the formula, let us look at here. When you want to find 54 square, I can write it as 50 plus 4 whole square. 50 plus 4 whole square, and don't write it as 50 square plus 2 into 50 into 4 plus b square. That is what we will write actually. Let us see and then find the result. So let us, even though we should not write 50 plus 4 whole square, we need not expand it, but to understand it, let us expand and then understand how it's going on. So this is 50 square plus 2 into 50 into 4 plus 4 square. So 50 square is 2500 plus 2 into 50 is always 100. So 100 into 400 here. So it is 400 plus 4 square. So here, instead of writing 2500, what we will write is, we will write 25 hundreds in your memory plus 4 hundreds in your memory. And what is remaining here? 4 square. This is what is remaining. If you observe, this is what is there. So in your school and or the board examination, you will be writing step by step. Whereas in a competitive examination, we will be writing the result. So what we are seeing in this method is nothing but we are applying a plus b whole square or a minus b whole square. Okay friends, so let's take one more example. 56 square. 56 square is nothing but what? In the similar manner, okay, how much it is more than 50? 6 more. 6 more is how much? 6 square. So first part is 6 square, that is 36. Second part will be what? 25 plus 6, that is 31. If you add a single digit number like this, 53 square also, method is same. 3 square, that is 9. So we have to write 09 single digit number. So 25 plus 3, that is 28. If you have, let us say 61 square, how much more than 50? 11 more. So 11 square is how much? 121. So 21 carry 1. Second part will be what? 25 plus 11, that is 36. 36 plus 1, that is 37. If I let us say 64 square. 64 square is how much more than 50? 14 more. 14 square is how much? 196. So 96 carry 1. Second part will be what? 25 plus 14 plus 1. That is how much? 40. So 4096. Okay friends. Now let's move to the last part in this model, that is numbers which are less than 50. So when you have numbers which are less than 50, the method is the same. No change in the method. Slight modification. So when you're talking about 26 to 50, okay, now let us take an example of 48 square. So what is the first step? Compare with 50. How much is 48 less than 50? 2 less. So first part will be what here? 2 square. What is the second part? Base number 25 minus 2. So 2 square is 4, that is 04. 25 minus 2 is 23. 2304. If you take an example of, let us say, 46 square, how much it is less than 50? 4 less. So first part will be 4 square, that is 16. Second part will be what? 25 minus 4, that is 21. 2116. Suppose if you have, let us say, 41 square. 41 square is how much less than 50? 9 less. So first part is 9 square, that is 81. Second part will be what? 25 minus 9, that is how much here? 16. Suppose if you have, let us say, 38 square, it's the same logic. How much less than 50? 12 less. So first part will be 12 square. 12 square is how much? 144. So 44 carry 1. Second part will be what? 25 minus 12. What is 25 minus 12? 13. 13 plus 1, that is 14. 1 triple. Okay friends. So now what will we do is, we'll look at some of the important points under the squares. Okay. Now, some of the important points under the square is, now before we look at important points, let me tell you one more method of finding the squares. Okay. As I told you, there are many methods. Okay. Just an observation. Now if you look at 21 square, 22 square, 23 square, 24 square, 25 square, 26 square, 27 square, 28 square, 29 square, like this it continues. we are supposed to remember the squares of the numbers till 25. Okay, so what is 21 square? 441. 22 square is 484. 23 square is 529. 24 square is 576. 25 square is 625. Now if you want to find out 26 square, 26 is how much more than 25? This is 1 more. What is 1 less than 25? That is 24. What is the square of 24? 576. Okay, for this add 100, you will get the square of 26, that is nothing but 676. That means you need to add as many hundreds as the number is more than 25 to the square of a number, okay, that is less than 25. Okay, if you look at 23 square, 23, or if you want to find 27 square, 27 is how much more? 2 more. What is the square of a number which is 2 less than 25? That is 23. For this 23, add 200, that will be 729. That is the square of 27. If you look at 28 square, 28 is how much more than 25? 3 more. Okay, what is the square of a number which is 3 less than 25? That is 22 square. 22 square is 484. Add here 300. That will be how much here? 784. Similarly, here you will be getting it as, add 400 here, you will get as 814. So this is one of the observation, okay, or one of the methods of finding the square of a number. Like this, there are so many methods which are there to find the square of a number, but whatever methods we have seen, okay, that is more than sufficient to crack a competitive exam. Okay, now, okay, some of the important points under the squares. Okay, let us start with the first point, and that's the first observation. Now, if you look at here, the square of a number, let us write the sum of the squares of the number. Okay, now, when you look at the important points under the square, let us look at the first point. In the first point, let us write what is the last digit of the number. The last digit of a number can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. What will happen to the square of the last digit? Okay, when you look at the squares here, the last digit, what will happen? 0 square is 0, 1 square is 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81. Now let us look at the cube of a number. The cube of a number will be 0 cube is 0, 1 cube is 1, 2 cube is 8, 27, 64, 125, 6 cube is 216, 7 cube is 343, 8 cube is 512, 9 cube is 729. So what is the observation you can make? Okay, 1 and 9 are tens complement. Okay, when 1 and 9 are tens complement, what is happening to the square? 1 and 9 is also the last digit is the same. 2 and 8 are a tens complement. So what will happen here? 4 and 4 are a last digit, that is same. Similarly, 3 and 7 are tens complement. So last digit of the squares will be 9 and 9, which is the same. That means if the last digit of two numbers are tens complement, the square of the last digits will be the same. Whereas if you look at for the cubes, 1 and 9 are tens complement. The cubes are what? 1 and 9. Again they are tens complement. 2 and 8 are tens complement. 8 and 2 are again tens complement. 3 and 7 are tens complement. 7 and 3 are tens complement. So if the last digit of two numbers are tens complement, the squares will be the last digit of the squares will be the same, whereas the last digit of the cubes will be also the tens complement. That's first important point. Now let us look at second point. In second point, if suppose somebody asks you, can the square of a number end in 1? The answer is yes, it can end in 1. Can it end in 2? If you observe it, there is no 2 here. That means it can never end in 2. Can it end in 3? By observation, we can say it is not ending in 3. 4, yes. 5, yes. 6, yes. 7, not possible. Similarly, 8, not possible. 9 is possible. 10 is nothing but 0, that is also possible. That means the square of a number can never end in either 0, can never end in 2, 3, 7 or 8. The square of a number can never end in 2, 3, 7 or 8. Okay? Whereas if you look at cubes, can it end in 0? Yes. 1, yes. 2, yes. 3, possibility. 4, yes. 5, yes. 6, yes. 7, 8. 7, 8, 9, everything is possible. So only the square of a number can never end in 2, 3, 7, 8. That's second point. Okay, now let's move to the third point. Okay, to understand the third point, let us take a example. Okay, the example is, if a question is asked, okay, is the 4-digit number ABCD a perfect square? The question is ABCD a 4-digit number a perfect square? Now, we are taking this example to understand the importance of the third point, and also how the questions in the competitive examination like CAT, okay, can be asked only in using the speed math techniques. So using the speed math techniques, will there be any question in the competitive examination? The answer is yes. And what is the question? That is what we are trying to solve it. Okay. Now, is the 4-digit number ABCD a perfect square? Now, first statement says the value of A is 9, the value of B is 2, and the value of D is 6. Second statement says the value of A is 9, the value of C is 4, and the value of D is 6. Now the question is, which statement is sufficient to solve the problem? Question is, which statement is sufficient to solve the problem? Is it the first statement, second statement, or both the statements? Think about it. So what will be the answer? Some of you might be thinking one is the answer. Some of you might be thinking both the statements are answer. Okay, so let us see what is the actual answer is. Now, to understand this problem, okay, we have seen in the second point, we have seen the importance of the last digit. So last digit of a square of a number, can it end in 0? Yes. Can it end in 1? Yes. Can it end in 2? No. 3? No. 4? Yes. 5? Yes. 6? Yes. 7? No. 8? No. 9? Yes. This is a last digit of a number. So what will happen to the tens digit? What will happen to tens digit? Let us see. If the last digit of a square of a number is 0, what will happen to a tens digit? Let us take an example. 10 square. 10 square is how much? 100. Last digit is 0. 10 digit is also 0. If you take 40 square, 40 square is how much? 1600. So last digit is 0. 10 digit is also 0. That means whenever the last digit is 0, 10 digit has to be 0. It cannot be any other number. Similarly, let us look at 5. If the last digit is 5, what will happen to the tens digit? How to find the square of a number ending in 5? You remember? Let us take an example. 15 square. What is 15 square? 5 square is 225. 2 the next number is 3. 2 into 3 is 6. Sorry, 1. 1 into 2 is 2. 225. Suppose if you have 25 square. 5 square is 25. 2 the next number is 3. 2 into 3 is 6. 35 square. 5 square is 25. 3 the next number is 4. 3 into 4 is 12. If you observe, the last digit is always 25. The last two digits are always 25. That means if the last digit is 5, that means the tens digit has to be 2. It cannot be any other number apart from 2. Okay? Now let us look at the next one. If the last digit is 1, what will happen to the tens digit? If the last digit is 1, tens digit, let us take an example. 9 square. What is 9 square? 81. Then let us take an example of 11 square. 11 square is how much? 121. Then 19 square. 19 square is how much? 361. 21 square is how much? 441. If you observe, when the last digit is 1, what is the tens digit here? It can be 2, 4, 6 or 8. What are they? They are the even numbers. Fine. Similarly, if the last digit is 4, what will happen to the tens digit? Last digit 4, when you are going to get? Example 8 square. 8 square is how much? 64. Then your 12 square, 144. 14 square, 19. We want 4. So 18 square, 324. 22 square, 484. Again, if you observe, when the last digit is 4, tens digit is what? Either 2, 4, 6, 8 is again even. If the last digit is 6, what will happen? Can you try out now? 6, when you will get 14 square, 14, let's start with smaller number. 4 square, 4 square is 16, 1, 6. Next 6 square, 36, 3, 6, 1, 3. The moment you look at 1 and 3, what you can think? It has to be odd. It has to be odd. Similarly, if you look at 9, okay, how much will be getting 9? Example what? 7 square. 7 square is how much? 49. 49 is 4. So that is sufficient, and then you can practice it. It has to be even. So when you know the units digit, we can find out what could be the tens digit. Meaning it can be either even number or odd number. Now let's come back to our problem. In our problem, what it says? Let us look at the first statement. The first statement says we have A, B, C, D. The first statement says A is 9, B is 2, C value we don't know, D value is 6. So is it possible to say whether it's a perfect square or not? This question mark which is there, this can be an even number or it can be an odd number. If it is an even number, then we can say it is not a perfect square. Because when the last digit is 6, tens digit has to be odd. Okay? So first statement, we don't know whether it is even or odd. So first statement is not sufficient to get the answer. Now let us look at the second statement. What the second statement says? For A is 9, B value we don't know, C is 4 and D is 6. The last digit is 6, so tens digit has to be odd number for it to be a perfect square. But here is given as even number, so this is an even number. So can we say it's a perfect square? The answer is no. It's not a perfect square. So we got an answer using the second statement alone. Okay, so what's the important point we have seen? So when we know the units digit, we know what could be the tens digit. That's the third important point. Okay, friends. Now let's move to the next important point. That's point number 4. In point number 4, let us take an example 41 square. 41 square is a very important number. Why 41 square is an important number? Because 41 square is what? 1681. So what is important of it? The important here is this is only 4-digit number. How many 4-digit number are there? 4-digit number starts from 1000, goes up to 9999. So how many 4-digit numbers are there? Totally 9000 4-digit numbers are there. Out of 9000 4-digit numbers, there is only one 4-digit number where the first 2 digits are perfect square, the last 2 digits are perfect square, and the number is also a perfect square. Fine. Next point. Fifth one. The fifth one, let us look at like this. You know the value of 11 square? How much is that? 121. 111 square is how much here? 12321. If you have 41 square, that will be how much here? 1234 321. So if you observe, this is a palindrome. If you read from left to right or from right to left, it is the same. Point number 1. Second thing it starts from 1, goes to a number which is equal to a number of ones. Here if you look at 4 ones are there. So it starts from 1, 2, 3, 4 equal to number of ones, again in a decreasing order. Now this is one of the questions which came in a number of times in a competitive examination. The question was, it was like this. What is the square root of 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1? So what will be the answer? It's a palindrome in the sequential order as what we have seen earlier. And to find a number of ones must be equal to the middle number here, that is 60 in this case. Okay, so how much you will be getting? How many ones? 1, 2, 3, 1, 2, 3. You will be getting 6 ones. Okay, friends. So this is these are some of the important points, okay, under the squares. We have seen how to find the square of a number in different methods. We have seen how the questions can come in a examination. Okay, question the units digit and the tens digit. Okay, so practice whatever we have seen 5 minutes a day. That's more than sufficient. Okay, now let's move to the next concept, that is multiplication methods. In multiplication methods, there are many methods, like how to multiply numbers which are in the range of 11 to 19. Then we have how to multiply numbers in the range of 5, 25 and 125. Then numbers which are close to powers of 10. Then 2-digit multiplication and the 3-digit multiplication. Okay, so let us start with 11 to 19. How to multiply numbers in the range of 11 to 19. Okay, now when you are talking about 11 to 19, let us see an example. Suppose if you have, let us say, 63 into 11. 63 into 11, how to multiply? What is the best method of doing it? Doing it orally. 63 into 11, you can write it as 10 plus 1. So it will be 630 plus 63. That will be how much? 693. What is we are saying? 630 plus 63, that is 693. Similarly, if you have, let us say, 54 into 11. What is the best method? 54 into 11 is nothing but 540 plus 54. Okay. If you have, let us say, 72 into 11. 72 into 11 is what? 720 plus 72. That is 792. Okay. So when you have 2-digit number, if you want to multiply with 11, this is the fastest method of doing it. Okay. But imagine a situation where, okay, you have a number something like 6259 into 11. Can I apply the same method? Yes, you can apply the same method. Okay, same method means what you will be writing? 62590 plus 6259. And after writing numbers, you have to add the numbers. How to add the numbers? Left to right or right to left? In this direction, left to right. So how much will be getting here? 6, 8, 8, 4, 9. Okay, this is one method of doing it. Now let us look at one more method of doing it. Okay, and the second method is you want to multiply a number with 11. So at the beginning of the multiplication, keep a 0 at the beginning of the 0 and 0 at the end. So you have to multiply a number with 11, the unit digit is 1. Since the unit digit is 1, multiply the number with 1. So how much you will be getting here? 1 into 9, that is 9. After multiplying, add the digit to the right of it. So what is the digit to the right of 9? 0. So 1 into 9, 9. 9 plus 0 is 9. Second one, 1 into 5 is 5 plus 9. Okay, so how much you get here? 1 into 5 is 5. 5 plus 9 is 14. 14 carry 1. Next, 1 into 2 is 2. 2 plus 1 is 3. 3 plus digit to the right of it is 5. That is 8. 1 into 6 is 6. 6 plus 2 is 8. 1 into 0 is 0. 0 plus 6 is 6. So you get 6, 8, 8, 9. The same. Okay. But if you observe, did we get the speed? We have not got the speed. We have seen the method. Let's take one more example. Okay. 7, 8, 8, 6 into 11. So what is the method? First thing is keep a 0 in the beginning and in the end. Okay. Then you have multiplying with 11. So unit digit is 1 here. So multiply the number with 1 and add the digit to the right of it. Now think like this. If you multiply a number with 1, the result will be the same number or different number? It will be the same number. Since the result is the same number, is it necessary for us to say 1 into 8 or 1 into 7 like this? Not necessary. Just observe the number and keep on adding the number to the right of it. Like this. 6 plus 0, 6. 8 plus 6, 14, 4 carry 1. 8 plus 8, 16 plus 1, 17, 7 carry 1. 7 plus 1, 8, 8 plus 8, 16, 6 carry 1. 0 plus 1, 1 plus 7 is 8. So let's take one more example. 4, 5, 6, 7 into 11. So keep a 0 in the beginning, in the end. So what you will be getting here? 7, 3. What you are doing? Adding the digit to the right of it. 7 plus 0, 7. 6 plus 7 is 13. 3 carry 1. 5 plus 1 plus 6, that is 12. 2 carry 1. 4 plus 1 plus 5, that is 10. 0 carry 1. And then you will get 5. Okay. With a little bit of practice, okay, you will get the speed. Meaning, let us take an example. 3, 4, 6, 7 into 11. So 0 in the beginning, 0 in the end. So how much will be getting here? 7, 3, 1, 8, 3. That is the speed with which you have to solve the problem. Okay. So method of 11 is what? Just add the number to the right of it. Okay. Now let's look at, instead of 11, had it been 12, what will happen? Let us take the same example, 6259 into 12. Now what is that you have? You have the unit digit as 2. So what should you do? Since the unit digit is 2, multiply with 2 and add the number to the right of it. Multiply with 2 and add the number to the right of it. So if you are multiplying a number with 2, what is the result? It will become double the number. So don't keep on saying 2 into 9, 2 into 5, 2 into 2 like this. Just observe the number, double the number and add the digit to the right of it. So what do you have here? 9. 9 double 18. 18 plus 0, 18. 8 carry 1. 5 double 10. 10 plus 1, 11. 11 plus 9, 19. 9 carry 1. Okay. 2 double 4. 4 plus 1, 5. 5 plus 5, 10. 0 carry 1. 6 double 12. 12 plus 1, 13. 13 plus 2, 15. 5 carry 1. 0 double 0. 0 plus 1. 1 plus 6, 7. Let's take one more example. 7225 into 12. Method is 0, beginning and in the end. So what will happen here? 5 double 10. 0 carry 1. 2 double 4 plus 1 5 plus 5 10 0 carry 1, 2 double 4 plus 1 5 plus 2 7, 7 double 14 14 plus 2 16 6 carry 1, 0 double 0 1 and 7, that is 8. Okay friends, so what we are doing? Doubling the number and adding the digit to the right of it. Suppose if you want to multiply with 13, then what should you do? Yes, triple the number and add the number to the right of it. Triple the number and add the digit to the right of it. Now this method is best applicable, okay, for 11, 12 and 13. So if you want to multiply a number with 18, what is the best method? 18 can be written as what? 20 minus 2. 18 can be written as 20 minus 2. Okay, 17 can be written as 20 minus 3. That is faster when compared with this. You can do this method also. Into 7 and add the digit to the right of it. Either way you will get the answer, but it's much faster for 11, 12 and 13. Okay, now let's move to the next concept, that is multiplication method of 5, 25, 125, how to do it. Now if you want to multiply with a number with 5, let us say 2, 4, 6, 8 into 5. Now ask a question. Dealing with 2 is faster or dealing with 5 is faster? 2 is faster. So 5 you can write it as what? 10 by 2. That means just divide a number with 2. Okay, so how much you'll be getting here? 1, 2, 3, 4 and then add a 0. Let's take one more example. 4, 7, 8, 6 into 5. So how much you'll be getting here? 2, 3, 9, 3, 0. Just half the number. Okay, now let's take one more example like 7, 4, 8, 5 into 5. Now if you observe here, how much you get here? 3, 7, 4, 2. Remainder you are getting. Remainder is 1. Whenever you are getting a remainder as 1, put the last digit as 5. Okay. So if the remainder is 0, last digit will be 0. If the remainder is 1, then the last digit will be 5. And when you are dividing a number with 2, the remainder can be either 0 or 1. That's it. Okay, let us take one more example. 3, 5, 7, 9 into 5. So this has to be written by 10 by 2. So how much you will be getting here? 17, 34, 1 7 means 8, 16. Correct? 1 9 means 9, 18. So remainder is 1. So it has to be. So when you multiply a number with 5, it has to be divided by 2 and the last digit can be either 0 or 5. Okay. Now let us look at the next one, that is (25). So if you are multiplying a number with 25, 25 can be written as what here? 100 by 4. So when you are dividing a number with 4, then what will happen? The remainders can be either 0, 1, 2 or 3. If the remainder is 0, then the last two digits will be 0, 0. When you are dividing with 5, you got last one digit. So when you are dividing with 2, you got last one digit. When you are dividing with 4, you will get last two digits. If the remainder is 0, last two digits will be 0, 0. If the remainder is 1, last two digits will be 25, 2 means 50, 3 means 75. Let us take an example. Okay, let us say 4, 9, 9, 8 into 25. Okay, this 25 you can write it as how much? 100 by 4. So divide by 4. Take the first two digits. How much you get here? 12 times. Okay, 48. 19 means it goes 4 times 16. 38 is how much? 9 times. And what is the remainder? 2 is the remainder. 2 is the remainder means last 2 digits are what here? 50. Let's take one example. 7486 into 25. So divide by 4. So first 2 digits is 18. 4 18 times 72. So you get 28. 28 means 7 times 4, 1 time, remainder is 2, again 50 you're getting. Okay. Suppose if you add, let us say, a number 6785 into 25. So by 4 means 16 times 64. 38 means 9 times 36. 25 is 4 times 6 times. So let's take one more example. 6785 into 25. So 100 by 4. So for first 2 digits will be 16 times 64. So 3, 8, 9 times 36. So 2, 5, 6 times 24. 1 is the remainder. So last 2 digits will be 25. Okay. So let's take one more example. And then we move on to the next one. Okay, let's take an example as 2364 into 25. So by 4 means if you take the first 2 digits, that will be how much here? 5 times 20, 3, 6, 9 times 1, and then you'll have 2 zeros. Okay friends, so now let's move to the next concept, that is 125. Okay, so what will happen with 125? The same method. 125 is nothing but what? You can write it as 10 by 2 into 10, or 5 into 5 into 5. 5 into 5 into 5, that is nothing but 125. Each 5 is 10 by 2, so this will be 1000 by 8. So what will happen? You divide the number with 8. So when you are dividing a number with 8, then what will happen? The remainders can be either 0, 1, 2, 3, 4, 5, 6 or 7. If the remainder is 0, then you will get last 3 digits you will be getting here. Last 3 digits will be 0, 0, 0. 1 means 125. 2 means 250, 3 is 375, 4 is 500, 5 is 625, 6 is 750, and 7 is 875. So let's take an example. 9876 into 125. If you want to multiply 9876 into 125, the best method is 125 you have to write as 100 by 1000 by 8. 1000 by 8 means you have divided the number with 8 here. So how much will be getting here? 8 12 times 96, 27, that is 3 times 24. 27 minus 24 is 36. 36 means 4 times 32. Remainder is 4. If the remainder is 4, the last 3 digits will be 500. Okay. Let's take one more example. 8989 into 125. So what will happen if you are dividing with 8? So first 2 digits is 11, 88. 182 means 16. Okay. So 29, 3 is 24. So remainder is again 5. 29 minus 24 is 5. 5 is the remainder, means last 3 digits will be 625. Okay. So 5 means, just to recap what we have done, if you want to multiply a number with 5, so it has to be divided by 2. Multiplication with 25 means divided by 4. Multiplication with 125 is divided by 8. Okay, and depending on the remainders, you either get last digit or last 2 digits or last 3 digits. So friends, we have seen some of the methods. What are the methods we have seen? First one is, we have seen what are the prerequisites. Then we have seen how to method of addition, the 2-digit addition method. Then we have seen squares. In squares we have seen 2 or 3 different methods. Then we have seen how to multiply the numbers. In the multiplication methods, we have seen the first 2 cases. That is 11 to 19 and 5, 25 and 125. Now the remaining part, that is numbers close to powers of 10, 2-digit and 3-digit multiplication, that we'll be seeing in the next session. Now before we wind up in this session, okay, we have seen so many methods, some techniques we have seen. So please practice these techniques, okay, and a continuation of this we'll see in the next class. Thank you.